Great. So
Good
we
morning.
talked about some of the struggles of syntax last time, and we realized that it is sort of like a necessary evil. We can't really get anything done without it. But hopefully, over the past two lectures, if you attempted the assignments and gone through the lecture materials, you might be getting used to some of the syntax. If there's anything specifically in the syntax that confuses you, that does not make any sense, then please feel free to drop me a message or ask a question on GitHub on the issues, or stop me right now and ask me. Because that does happen, but usually there is a reason or there is a pattern that you can observe, which you may not be observing right now, which may make life a little easier with syntax. So assuming that you are sort of fighting with your syntax, and if there's any help you need with that, please feel free to ask me. Yeah, so the plan for today that we have is I'll give a quick recap. And we'll have a flipped classroom. So Malvika and Rajshri, who did some pretty good stuff on the second assignment, we're going to present their assignment today. Rajshri, I think, is unwell, so she hasn't been able to join us for the class today. So Malvika will be presenting her presentation. They'll be presenting their assignment together. And after that, we will have a very quick introduction to HTML, which is, it's very essential to understand how web pages are made before we can start scraping them. So it'll be just a couple of slides on HTML to explain you what's happening. And then we'll learn how to scrape a web page, which is basically a page written in HTML. So yeah, a quick recap. We talked a little bit about objects. We talked about how they're Lego blocks. We talked about an algorithm, which was basically a schematic to put together these blocks to build something useful. In typical computer science classes in the university, when they talk about algorithms, they tend to talk about something slightly more, I would say slightly more complicated than the kind of algorithms we've seen, because the only algorithm we've seen so far is how do you go about reading text from a file and then printing it or plotting it and so far. Though even that can be called, you can, what the structure that you write, the set of steps that you write for it could also be called an algorithm in terms of like layman use. Typically, when people talk about these things in computer science classes, they would be talking about things like, suppose you have a very long list of numbers and you have to sort them. Then how would you sort these in a way which is the fastest? That is the most quintessential algorithm that you come across. And in fact, there is a whole class dedicated to algorithms, or almost two classes dedicated to algorithms in typical computer science undergraduate. But that is stuff that you can keep learning alongside. Once you can get something, you can build something, you enjoyed building it, you can keep learning on your own time. And I think it's not very difficult to go and look up something online and learn, specifically in computer science, given how much is available online. So we talked also about lists. We talked about how to read files. And here's a quick practice problem that I wanted to add for people is using the syntax to read files. You can change the syntax just a little bit to start to write to a file. That is, you have some content that, imagine you do some process in your program, and at the end, a number is generated. And you want to print the output of this program instead of to your computer screen. You want to print it to a file which can be stored for later use. So the syntax doesn't change very much beyond the read files syntax. And it's a good practice for you to go look up online how to make that change and just try practicing writing something to a file. We also talked about how to visualize the code flow. We saw the steps that a program was run in. And I strongly encourage you to do this again with any other code you may be working on. In the starting stages, it's very useful to understand how the computer is processing your code. It's almost like saying, to be able to tell the computer what you want to say, you first need to understand what does it understand. So you need to understand how it reads your code, how it goes through your code step by step, and that sort of builds intuition for how to write it better. Quick recap, we also talked about dictionaries, which is another kind of data structure like lists, which means a structure to hold data. We talked about key value pairs. This is just a quick example of how do you create an empty dictionary and how do you add information, how do you add a key and a value to a dictionary. We talked about how values can be basically pretty much any kind of data structure. In fact, you can store a dictionary inside a dictionary to make a dictionary of dictionaries. That's very common in Python. A lot of languages don't allow that, but Python does allow that. So we're lucky there. Right, and we have if-else statements, which allows you to basically, if you want to run a piece of code based on some variable value, something like making a decision, it allows you to do something of this sort. That's a recap of if-else for you. We also talked about functions, which is, just think of it as the code block, which takes as an input and an output. This is just to help you understand it. Essentially, you could also have a function which does not have an input. You could also have a function which does not have an output. But the general structure is to have an input and an output. Again, this is Python specific. Different languages have different constraints, but this is the way it is in Python. Here's an example of a function we saw, which allows you to execute Pythagoras theorem. It takes in the two sides of a right triangle and returns the length of the hypotenuse. And you can see that it calls on a function squared, which is not written here, which we had defined in the previous class, which takes in a number and just squares it. The important thing again is that you need to have the def statement to define a function. You need to define the inputs inside the bracket. You have to define the name of the function right next to the def statement. And you have to return something which basically tells the output of the function. Cool. So I think this is a good point for us to stop and see what Malvika has to present with her code, because it's going to be a quick recap of everything that we've seen so far. And the assignment was just to extend what we had in assignment 1, but also to add some interesting functionalities like adding say titles and things like that. So I'm just going to allow screen share, and Malvika can take it forward from here.
Yes. Spandan, I think the screen sharing has been disabled.
Can you try once more? I just enabled it.
Yeah, it's working now. Hello?
Yes, we can see the screen.
Okay, so the task basically for this week was using everything that we learned in the second lecture, that is using functions, if-else conditions. So basically, what I did was, I thought, okay, we are supposed to write a code wherein we are not repeating it for now we have just 2 countries, but what if you have multiple countries? So for that, I use the function, and as Spandan has told us in his previous lectures, whenever we start writing a code, the first thing is to import all the modules so that there's no confusion at the end of the code. So I started with importing the modules, that is NumPy and Matplotlib. Then for function, I started with defining the country details. Okay. This was basically the name of the function that I created. The main thing, and this was while writing the code that I faced, was the use of the double equal to signs and the single one. At first, I thought there was an error while Spandan gave a demo during the class, but then I read, and basically this is used when we have to, like, the name of the country can be changed, whereas the file path, it's a defined, we can call it a defined attribute. And so first, if the country is Canada, for example, it will choose the file path. It will, right now, I'm not going to print the file path, but if I enter any third country, for example, Africa, South Africa, it will give me the data as the output will be that no data is available for the country. The next step is, now, if I enter the name of the country as Canada, I have the country, I have the file path. The computer is supposed to open that, and it will read through this. It will go through that, okay, I have created these 3 lists, which is total confirmed, total deaths, and recoveries. Then I will loop over. It has to read from 1 to the length of the content. Then I basically the split function to remove the spaces. And like Spandan just told us, when we are using the functions, we are supposed to define what it is supposed to return us at the end. So if I write here, if I want to see the result for Canada, for example, I go here and it will give me the list of all the confirmed cases for Canada. Then I will go and create a dictionary, because I am associating it. It is not just the list of confirmed cases, but for which country. So there's a key and there's a value. Once the dictionary is created, I will sort that data. And for my graph, as you can see, I did some customization. Now here, I don't need to define my module again, because I've already done that at the beginning of the code. So we will use the same command, that is plt.plot. instead of the list, like in the first assignment, here we will write the name of the dictionary that we have created. And this label is the label of the graph line which is going to come. And I change the color. For example, I use blue for Canada. Similarly, for India, just to see what all functions or attributes I can play with, I change the color and then the line style and the width as well. I also gave the X and Y axis, the names, for example, number of days for X axis, and the number of confirmed cases for Y axis, and the graph title as well. At the end, you are supposed to write plt.legend. Legend is basically all the attributes of this graph. And then the plt.show, if you put this command, it will just give you the graph with all the functions and the descriptive features that I have stated here. Now, when we write this plt.legend, we are not supposed to repeat all these features because it will just go and read that, okay, when I have to plot the graph, when it will pick the value for Canada, the trend line should be in this color. For India, it should be in this color. For third, any other country, I can just, if I have a new country, for example, I will upload the file, I can change the file path, and I will have all the graph and the trend lines that I want. So I felt that contrary to the first assignment, this is much more user-friendly, and I would say it will really help me in real life, and I'm very happy to do this. The only problem, Swandan, I want to ask you one question here.
Sure, go ahead.
Yeah, so for example, like I have written the function, when I started writing the function, so from define, is this like this def, is it called define?
I mean, it is used to define a function, yes.
Yes.
It's
Okay.
just called, I mean, I don't think it's called anything specifically, but it's fine. You can call it whatever. It's okay. Yeah.
Okay. So if I like break the code, and this was the issue that I had earlier as well, like instead of writing all of this together, if, you know, after this line, for example, I add the code and I break this code, like if I am writing this with function here, then sometimes there are errors, but then I don't know why this is
Yeah.
happening.
So what you're talking about is something called scoping, variable scoping. I will talk about that in the future class. It's a slightly more complicated idea, but just as a foreshadowing, basically what that means is that if you, in the simplest terms, if you define a variable inside a function, you can think of function as a container. So whatever you define inside it is not known to the world outside it. The only thing the world outside gets to see is what you return outside. So if you define the file path inside the function, inside the def function code, and then you try to use that thing outside, it will not be able to access it because the outside world doesn't know there is a variable called write path that can only be seen from inside the function. And the reason that's done is it's just to, it's a little complicated. Let's not go into it right now. But essentially, it prevents a lot of errors by making sure that you define something in one box and then it stays inside that box until you actually force it to be available to other boxes.
Right. But similarly, like when we are creating dictionary, because it is a different thing, then dictionary is not affected.
Well, that's because you're creating outside a box.
Okay, okay.
So if you created this dictionary inside the box and then you try to use it outside, it would again be inside a function that is, and try to use it outside, it would again be an error. So essentially, that's something that depends upon basically where you're creating it. So sometimes we need to use things outside a function, and there are ways to do that. But usually, you don't want to do that usually because it leads to errors. Okay. Great. Yeah, that was pretty amazing. I thought that all the things that you did with the plot was very nice. It looked really nice. And one important thing that you touched on earlier was the equal to versus double equal to. And that's actually a very important thing. So when you use a single equal to, that basically means that you're setting the value on the right equal to the variable on the left. So in your code here, if you go up, yes, we can see here, file path is a variable, and we set this string as the value of file path. So it gets stored there. But here I'm not setting the value of country path. I'm just checking if it is equal to Canada. So when you want to check if two things are, so when you want to do LHS equals RHS, you want to check that, you use a double equal to in Python. That tells it that this is a check thing, this is a check statement, and this is an assignment. So it assigns the value on the right to the left. So this is a very important distinction. And this is actually an error that, whenever you're trying to code fast, it keeps happening, but it's important to keep it in your mind that this happens. Cool. Thanks a lot for this presentation. So we can quickly move on to the next part as well. Yeah, I can start sharing the screen. Great. Can you see my screen again?
Yeah.
Great. So we've learned quite a lot of very basic Python functions. In fact, if you go and check the online tutorials on Python and the official documentation tutorials for Python, you've actually covered already the 70% of the basics. So in doing all of this basic exercise that we're doing, we've actually learned a lot. And today I wanted to introduce you to something slightly more cooler, something which you can use to probably make a project, because at the end you want to make a project. Everybody can make a project, hopefully. So today is going to be about getting data from the internet, scraping information from the internet. And in the next class, we'll sort of build on this to analyze the data that we scrape. So this gives you a brief flavor of both the two important things that people tend to use Python for, or programming for, in fact. So web pages are written in HTML. That's another language. We will not go into it too much, but just to understand enough to scrape the internet, I'll give you a very little brief introduction. So web pages are written in HTML, and HTML is made of tags like this. So if it starts with the less than and closes with the greater than symbol, it's called a tag. So HTML, title, IMG, these are all tags. You can again think of them in terms of like, Lego blocks that you put together, and that allows you to create a web page. And the order in which you put them together defines how things look on your screen. Each of these tags can also have associated values, just as we had with objects, we had attributes that we defined earlier. Same, each of these tags comes with something called an attribute, which allows you to increase the customization of each of these tags. For example, the IMG tag allows you to show a picture on a web page. And if you want to show a picture, some common things you may want to do are things like, what is the URL of the image you're showing? What is the size that you're showing? Does it have a border? Things like that. So all of these attributes go into the IMG tag, as it's called, which allow you to customize how an image is shown. Tags in HTML usually, for the most part, tend to come with a start and a close tag. Excuse me. What that means is that the starting tag will look like HTML, like the one on the left, and the closing tag will start with a /. That tells the computer that this is where it gets closed. HTML is usually just read by the browser itself and then displayed. Let's not go into how it is different from Python or other languages, but essentially it's a relatively easier language to learn than some of the other things. So if you want to get into building a web page, learning HTML, if you want to do good cutting edge stuff, of course, that's difficult everywhere. But building a very basic web page in HTML will not take you more than a week to learn. This is an example HTML code. Let's break this up step by step. So as you can see, this is nested, which is that HTML starts at the top. That's the first tag. That is with every HTML page. It starts with the HTML tag and it ends with the HTML tag. Inside that, you'll have different sections. You can have the head section and you can have the body section. The head section usually contains metadata, which is not displayed on the page. For example, if you open a bunch of tabs, you can see that each tab has a name. That is the name given to the web page. That gets stored in the title. There are some other things you put into head, but for the most part, you can just forget the head for now. All that we're going to use it for is the title. And you have a body, which can have all the text, all the images, all the sort of different styles you may want for those things, and go on and so on. The important tag to see here is the P tag. The P here stands for paragraph, and every time you want to create a new paragraph, you start with the P, end with the P. So if I added another P and \P here, that would create another paragraph on this page. So I wrote a very quick page which has these things, and it looks like this. As you can see, this isn't anything fancy. It is just a page which displays this text, and it has a redirection link. So if I click on this link, it takes me to Wikipedia. That's all. This is how a browser shows it to you. But how do we write it in terms of HTML? We'll have to open this in something called a text editor. I use this one called Atom. There's a bunch of different ones you can use. You can also open it in Notepad. But this is what I have to write so that it gets displayed like this on the browser. So here we have the HTML, we open the head section. Inside that, we define the title. We again close the head section. We come to the body section, we create a paragraph. Inside that paragraph, I write this text. And then this is a link. So this is a little more complicated. A just says that, this is a link. href basically specifies the URL where I am to be redirected when I click this link. And this is what is displayed on the browser as its name. So here is the text that is displayed on the link. This is the URL I would be taken to when I click it. And this A tag and the close A defines the extremities of how much is the link. So for example, if I put this text inside this tag here, and then I open this page again, you would see that this whole has become a hyperlink now, which was not the case earlier. So the reason I wanted to give you this very quick introduction to HTML, specifically the A and the P tag, is because bulk of web scraping that we do revolves around getting text from a page, revolves around getting links from a page, and if there is a link on a page, sort of traveling to that. So this is called web crawling. That is, you go onto a page, you find a link, you travel to that page, you find an interesting link there, you travel to that page. That is also how actually Google indexes their whole database of web pages. It crawls over websites and it identifies which pages are more important. That's how it ranks your pages. That in itself is a very interesting problem. But the reason why we want to do this is because we may want to get some links, get some text, go to those links and get the text from there, which we will see in the second part of this class. So a practice problem for you here is we just saw how you can use the A and the P tag, and I will add this small simple HTML page to the repository. It's also a very important, very useful thing to add images to your web page. So you can look up online how to use the img tag to add image to your website if you're curious. Great. So this brings us to the second part of the lecture, which is that we'll code. And the reason why today's code looks like just this, there's no code there, there's only commands, there's only a skeleton, is because we're actually going to Google and we're going to build this thing ourselves. So what all are we going to do? We're going to scrape a page from Wikipedia, we'll get the text, we'll get all the links on that page, and then we'll see how to put these two together to do something interesting, which is that we'll go and get a lot of transcripts for politicians. In the next class, we can actually try to go over these transcripts and compare how different politicians give their speeches, what are the words they use. We can do that, or we can do something similar with music, where we can go and get lyrics for songs from different artists and we can compare them. This one, I think Gaurav had mentioned this in his original motivation, so I thought this could be an interesting exercise to just touch on. Sounds good. We can do that. Great. So for the purposes of this class, we will stick to getting political transcripts. And if anybody is curious, they can, of course, extend that analysis to that domain as well. But all right, so when we're going to start working with Python on anything new, we talked about this earlier, which is that we first need to have a mental skeleton for how do we approach this problem. Imagine today that you want to learn to web scrape. You may want to do that because, for example, say you want to get a bunch of court cases from the internet which are available. If there's a possibility you may be curious in, we want to get some, for example, Anna, who's on this call, I believe, she wants to scrape a bunch of pages for her PhD project, where she wants to scrape curriculums of different universities so that she can compare how industry and universities work together, does it help, things like that. So this enables people to get things from the internet. And suppose we're a novice that knows nothing. The first question you may want to ask is, what is the module that I'll be working with? So the first question to ask is, web scraping Python. We're just going to Google this and we're going to see what we get. So we get a lot of stuff, and there's a lot of links, and some of them will look intimidating. So this one has a lot going on. this seems like too much. You don't want to sign yourself up for this much stuff. Seems pretty, lots of images, lots of text. You want to look for something simple. You want to look for like 5-6 lines of code that can be run and just get a feel for what's going on. So first thing to do is, what are the different modules? Here's one that shows up. So it says beautiful soup. Here's another one. One thing that I suggest that I struggle with a lot is not opening more than one sort of link at a time when you're trying to understand a new library, because you can get lost. So it seems like beautiful soup is something that is a library that people tend to use. And I will cheat a little bit. I have gone on and opened one link which seems to have some decent code for beautiful soup that we can work with. So the first thing that you do when you want to work with any module is you first have to install the module. The way to install the module is something called pip install and then the module name. I'll explain what's happening with the syntax here. So we're closing all the links and we're keeping open only the one that we want to use. Right. So pip is basically telling you can think of it as a program that installs other Python modules. This usually, I mean, you may have to install pip yourself, but for now, this collab comes with pip already. So we do pip install and then we write the module name and it gets downloaded. So as you can see, it says requirement already satisfied, beautiful soup in here. So the way this works is, I told you, a module is nothing but code written by somebody else. So a Python module would be other Python code that is written by somebody else, and it's already stored somewhere inside your Python directory. So all of these files are also just plain Python scripts. If you want, you can actually go and read it yourself to understand how this module works on whatever you want to do. For now, we're just going to use it. We won't modify the module. We'll write this. We'll just copy this bunch of code. We'll come here, and then now that this is installed, we can open another code. Then here we can do this. And let's just run this line by line, because we want to understand what's going on line by line. So this line, of course, is trying to import the module. We've seen this line before with matplotlib, with NumPy. It's just trying to import. So we just write this here, import any modules. We'll import this. All right, so we now know that the module has been imported successfully. If this module was not installed, and if we hadn't done this and we tried to install this, this would probably have given us some error like module does not exist or module not found. So then there's another module that we're using. It's called requests. We don't know what request is. For now, it's okay. Let's just go with this and see what we get. If we need to understand, it's important to sort of understand most lines, but also just keep running and seeing what you're getting. So here's a page. Let us try to scrape another page. Let's just say we go to Wikipedia and we search for Richard Feynman, who's my favorite scientist. And let's say we want to scrape the text on this page. Zoom is giving me troubles. Right. And what we'll do here, of course, this is a URL, so we just replace it with that. And as you can see, this sort of makes sense. Request is a module. We're calling some function just like np.mean for getting the mean using NumPy, or plt.plot is the same here. We're just using another. It's called requests. If you hover over it, you can actually see that it says it's a library, blah, blah, blah. You can hover over this and it shows you that it's a function, requests.get. So as you can see, you can tell it's a function because it starts with a def. Def requests.get, in the bracket it says URLs. So you give the URL and you run this. And then you can just copy paste the same lines that they have here. And we have something called soup. So soup, of course, must be an object. And it's unclear why it's called soup, what's going on with all of this, but it'll be clear in a moment. Essentially, soup is just an object that is created by this library, which allows you to read HTML code. So you can do, as you can see, soup.findAllA. Let's just look at this and try to understand what's going on with just this part of the code. When we run this, it shows you a list of ahref, ehref, ahref. These are all the A tags in this HTML file. It looks scary. I understand. It is scary. Let's also try to see what this page looks like under the hood. You can actually do that. You you can go ahead and you can search for something called view source. Now, this is, I'm not sure how to do it in Safari, but you can also do this in something like Firefox. And then we can do, we do the page source. It shows us the whole source of this page. So, it's a lot of HTML. It looks scary. I completely agree with you. I understand that you right now may think that this is very complicated. But as you can see, the only thing we want to see here is that there are tags. That starts with the HTML tag that has some attributes. We didn't define those attributes in our simple page. It has the body tag. Inside that, it has some other elements, some other tags. It's a nested object. But essentially, we don't care about that right now. All that we want to see is, can we get all the links from this page? We do this, it gives us all the links on this page. Great. Another thing that we may want to do is get the text. Now, how do we do that? First thing would be to search online. Let's just search beautiful soup, get text. Let's see what we get. Okay, we come here, keep scrolling. Here says this. Let's see what's going on here. Let's try to do this. And again, we can now understand that when we had this, it was giving us all A. When we do this, it gives us, maybe we should do something like this. Let's see what it gives us. This should hopefully return some text. That's not the most useful text. I think what's happening here is that we basically, when we do this, it gives us a list. Page is the list of elements, which has all the text there. But we just need to run .get text on one of them. And that takes a little bit of intuition or a little bit of Googling if you're new to it. But essentially, by making sense of this stuff, you can start understanding what's going on. So this, as we know, is a list. So what we can do is we can loop over it. So we can say for p in page, print p dot get. What is the syntax? Get text. And there you go. All the text is here. And we know already that this empty space happens because of the \n at the end. So what we need to do is our strip. This should look neater, and it looks neater. So that's, all the page that was inside this ugly mess that we saw in Firefox. You can actually just open it again just to see how scary it was. There, that's pretty ugly. Extracting all the text so nicely from this seems like a harder and daunting task initially, but if you start Googling, understanding, if you get an error, you Google that, ask someone, see if anybody's seen that same error. It's not very difficult. I can tell you that this is something I haven't done before because Beautiful Soup is not a library that I use myself. There are other ways to scrape the internet. Beautiful Soup is the easiest and I would say the least powerful of them, but it's good to get you started. I use something called Selenium, which is slightly more complicated, but it allows you to do a lot of stuff. But essentially, this is something that I've never done this before, and we just did it in front of you in 2 minutes. It wasn't very difficult. We can also just, now that we saw we can get all the tags using find all A, you get all the P tags using P. Of course, if there was a bunch of images on this page and we want to get all the IMG tags, we can probably just do this. I know we'll get all the images. And in a similar way, you can parse or you can go through all the tags in this page in a structured manner. So we've done this. We've gotten Wikipedia. Now let's try to get something slightly more complicated. Let's see if we can get this sort of transcripts of politicians.
Spandan, one thing.
Go on.
Yeah, just wanted to understand the difference between an A tag and a P tag in this particular page. I mean, what would we get if we pull all the A tags instead of the P tags?
let's just do that. So if we get all the A tags, and if we do, so A would typically be something like A.href. So the more relevant information you may want to get from A tags would be their href elements, which is like, where do you get redirected when you run this, when you click this link. So for that, we'll probably have to just go back to this tool and see how we do that here. So if we do this, and if I print this should hopefully print all the, yeah. So these are all the URLs that the page redirects to at different places. And these are all somewhere inside that page. You could actually probably see languages names at the bottom, because so these are all the links. And if you want to get the text at the link, you probably need to do something like, maybe this is an error. We'll see, we'll find out. Oh, it works. This has the links and the text of the link right next to it. So you can play around with this stuff, and every library has different functionalities. What we're discussing the syntax of right now is specifically the syntax of Beautiful Soup. So it's, of course, you would forget this. Even if you work with this, after 15 days, you'll forget if it was get text, if this was a small t, if this was a capital T, if it was this, because different people use different things. That's why it's very important to quickly go Google and understand what's going on. So right now we've just, tried to find a small piece of code that we can split line by line, understand where we have a module, where do we have a function, where do we use that function, what goes inside that function, how do we store this into a list. We've done such simple stuff. If you get slightly more advanced, what you can do is you can actually go and search for Beautiful Soup documentation. And this would again look very daunting, because, this would explain everything. It has all the code, and you can read, they explain what Beautiful Soup is. They would explain how to use it. They would explain all the functionalities. This is complicated. This is something that you would probably want to do after you have good enough experience with just getting started and learning how to do very simple things from Google. So now that we know how to do this, let's try to scrape something more fun, right? What we want to do is we want to get politicians' transcripts. So what I did was I actually searched, should probably get this out of the way first. Yeah. Politician transcripts, we search that. And so I already clicked and checked that this link works. So I'm probably cheating a bit, but shouldn't be very difficult. So here's a page, and let's see what we get by going all Beautiful Soup on this. We can scroll up again, and this time we can change this to this page. That's not right. Cool. And we go through this, and now let's try to again print all the links that we have here. So let's just take this line, run this, and see what we get. So if I was to that looks kind of ugly. That's because this is a list that is being printed like this. So one good practice in general is to name your variables right. Ideally, if you're storing links in it, you would want to store something like page links, because it just makes reading your code easier. There's different practices for naming in different languages, and I wouldn't be the best person to advise you on that. What works for me is basically just separating by these underscores. And usually I don't mind having a relatively longer variable name, 2 or 3 subsections in a variable name is fine. It can be, A underscore B underscore C. Try to keep it descriptive for yourself. So I would say for page link in page links, because page links is a list of where each element is a page link. If I do this should look neater. Right. So these are all the links, but I want to get the text of these links. So we probably need to get something like, I don't know if this works, but I have a feeling it's not going to work. Maybe I try this. All right, that works. That works. So these look like link names, basically. So as we talked earlier, you define an ahref element, and inside that you define some text that is displayed on the browser window, which tells you what that link is. So these are all the links that you want to get that might be useful. And of course, what you can do is you can now use an if statement, and you can use a list. So you can define useful links. And for each page link, what you can say URL can be stored in something like page_link.get href. And you can say text here. And now what you can do is you can check if there is a certain, say you want to check for just, all the transcripts that have, say, COVID-19 in it. So that seems to be something that everybody is talking about right now, it seems. So you can just search for this, and you can say if COVID-19 in text. Then you want to append this. And you run this. Okay, that's because this happened. And you basically have stored all the URLs on that page. Okay, these are all press conferences that talk about COVID-19. So now I could do this, and as you can see, these are nice transcripts. And I've basically just downloaded them with 10 lines of code that we learned right now how to do online. You could do more interesting things. You could just say def, scrape page, and that you could define this function that you could write a code here that takes in a URL, and it returns return content, something like that. And now what you can do after this is you can loop over each of these useful links. So you can say for link in useful links, and you can just call scrape page on each of them. This would be link URL, just to be slightly more specific about what we are naming. So as you can quickly see that, I can start combining dictionaries, I can start combining lists. For example, what if I wanted to get two kinds of transcripts? Say I was working with trying to find two politicians, and we want to get something like, I could just say something like useful links, and then I could have useful links Trump, and say useful links Cuomo, and we can actually just store to each of these relevant links by having an if, and then we can have an elif, just like we had before. So you can see how all of the concepts that we've studied so far, the functions, you can see how that's useful. You can see how links, lists, if else, dictionaries, all of these things become very important very quickly. And by combining it with a little bit of new things that you've used, something like Beautiful Soup, you can do very interesting things, because this could potentially allow you to go to the internet and scrape all the scripts over the past few days that have been made, all the comments that have been made about COVID-19 by, say, government politicians. And that seems like a daunting task at the face of it, but as you can see, it's very basic Lego blocks that we put together. The important thing is knowing how to get away with syntax. For syntax, we always just Google and check to make sure we're doing the right thing. We start with a small block, we make it work for a small thing, and then we build, we write. Then first of all, you may want to just run it for a small thing. Once your code is working, you can probably put it inside a function and then keep reusing it. You can extend your functionality beyond what you know already by by Googling it. If you want to get into something new, you first need to find out which module, and then it becomes very easy once you have some working knowledge of how to use that module. So yeah, I think this is basically all that I wanted to cover today. I can take any questions that you guys have, or if you think that I was very fast in the last part, I can go over it sort of slowly. Are there any questions?
So Spandan, if we wanted to, like, let's say, parse through the text in some of these links, then what we would be doing is, again, like Googling to understand what kind of modules are already there in Python that let us parse text, and then figuring out like which keywords you want to look for, and then setting that up, right? Like, so the idea is like define your problem, break it down into smaller pieces, Google to see what modules might fit, and
Right.
experiment with the text.
Right. I think that's very well put, and that's basically. So if you remember in the first class, I mentioned this a couple of times for like computational thinking. How do you think about going about a programmer solution to a problem? Is exactly what you just mentioned. You want to break up your problem into smaller parts. For each of those parts, you want to get a working knowledge of what are the existing ways, what are the existing modules that people use, and so in the next class, what we'll do is we talked about earlier in this class is. We'll probably go and scrape some musicians' lyrics and we'll compare to artists. So that would require us to go inside the contents that we scrape, the text, and analyze that. And we'll again use another library, another module. And I don't know what module it is right now, but say I just Googled it right now. Get important words from page Python, from text Python. It's as basic as it gets. And then I get this interesting thing. It says keyword extraction, automated keyword extraction. There's a lot going on. This one seems like a tutorial, and it says extracting keywords with TF-IDF and Python scikit-learn. So this is, I mean, it is a little bit of cheating because I already know what TF-IDF and scikit-learn and keyword extraction are. But you can see that I search for very generic stuff and pretty much Google helped me out here. Even if I picked this link and I just went through what's going on to understand, here you can see that, here's some stuff going on. Here's a bunch of text and there's pre-processing. You can extract the important words out of it. But essentially if you walk through this whole code base, this tutorial, you'll be able to get pretty interesting stuff done. And that in general is a very big, I would say very big, functionality, a very big strength of Python, that a lot of people are using it this way. And there's a lot of tutorials available all around which you can use for your own stuff. I have a tutorial of my own that I've written in the past for how do you use this stuff to extract things out of a bunch of text. I could point you to that if you want to work with something more complicated, but the idea is you can quickly grow out very easily. Right. If there's any other questions, I'd be happy to take them.
So just one more question. Like, is there a collection of techniques that on a website that we could look up?
Yeah.
On how to sort of what are interesting things we can do with text parsing?
Right. So in general for Python, I would suggest this very highly. Automate the boring stuff with Python. I think this is the best resource that I have found for enjoying with Python pretty much. It talks about some important things like so this was chapter 12 that we just talked about, and if you read through this chapter, it's much more detailed. It goes through a bunch of things, but it allows you to sort of read Excel sheets, reading PDFs and Word documents using Python, launching programs at a specific time. Say you want to run a program every night at 10 p.m. Sending emails, text. For example, I have a program which signals me every time a program that I'm running ends. For example, if I'm running some programs that takes a whole day, whenever it finishes, I get a text message that tells me the program is finished. So you can go check the results. Specifically to answer your question of understanding text, I can find a good resource and get back to you. But essentially, what you're talking about is text processing is the right word for it at the very base, I guess. So text processing, if you search this, there's a lot of things that you can do. NLTK is a very standard library that is used very often. You could use this if you want to get into it. But as you can see, this is actually already there's a lot going on here. There's text processing, like a lot of things that they're showing here that you can use. You can do spelling checking. You can do tokenization. Tokenization basically says get rid of the, for example, if I say read versus reading, it's pretty much the same word. You want to get rid of those things. Then you have something called stop words, which allows you to get rid of a and the, all those boring words that don't really contribute much to the meaning of the sentence. So you can do text classification, which says that if I give you a bunch of text, can you classify and say if this is a text about sports, or is it about say you have news articles and you want to classify them into sports articles, politics articles, and so on. But you can already think of this in terms of blocks or chunks. So it always requires you to first read in the data, get the data, clean the data, and then you can start modeling. So you already have everything that you need for the first step for text classification. From here on, you need to first find a nice library. You need to see its peculiar syntax that it requires, get comfortable with that, and then start using that for whatever end use you may have, basically.
Got it. Thank you.
Yeah, of course. Are there any other questions? About
Spandan, one
HTML,
thing.
yeah, go on.
So far we have looked at how we can download scrape website and download the data into an object, whether it is a dictionary.
Right.
From here, we can also write it into an external file.
Exactly.
Whether it could be a text file or an Excel.
Right. So probably you would want to store whatever data you scrape, because right now we just read it into variables, right? And then we stored and we just like printed it out. But you may want to use it later on. For example, the application that Shruti just mentioned, if you want to do text analysis, you first store your data somewhere. And to do that, you would basically write it to files, store it there, things like that. Yeah.
Got it.
Great. If there's any questions about the HTML part that we talked about, or about Python or general questions, I'd be happy to take them. Great. So I tried to keep today's class a little light because I realized that we had gone over a lot of stuff in the first 2 classes and it was a little intense. So the idea is to just keep reminding you of the way of thinking in terms of chunks, and remembering that it's very important. You always keep falling back to the very basic Python objects for the most part. As you get slightly more advanced in terms of coding, you probably want to write more. You need to create your own objects beyond just Python objects and things like that. But for now, you can get a lot done by just knowing the little amount that you know. And the assignment that I'll give you for this week is actually going to be scraping the lyrics of 2 artists. And if there's any suggestions for what artists you would want to see a comparison of, I think this is a good time. You can probably just write it in the chat, or you can probably just say it. So I'll just sort of just build an assignment around scraping a data set for that. And in the next class, we'll see how we can use that data set. So we'll go over what Shruti just mentioned. We'll try to compare the 2 artists' music through the lyrics, basically. If there's any suggestions, feel free to just write them in the text in the chat right now. So I'll just keep the chat for later.
Sounds great, Spandan. Thank you.
Great. Yeah. Awesome. So I guess we can end the lecture here, and I'll send out the assignment soon. And hopefully this is, in general, if there's any comments on improving the teaching or the material, please drop me an email. Feel free to drop me an email. It will only help us all. So yeah, that's all I have for today.